Okay, for our next lesson, we are going to be talking about direct variation. So this first blank is direct variation. Is a special type of linear relationship that can be written in the form of y equals k times x. Remember, k is also often referred to as m, where k is your constant of variation. Okay, so if you notice, the difference between this equation and all the ones we've been doing thus far is there is no plus b out there on the end. It says that the graph of a direct variation equation y equals k times x is aligned with the following properties. The line passes through the origin, which means your y-intercept is at 0, 0, which is why there is no plus b. So, no plus b in these equations. And the slope of the line is some value k. All right. So, we are going to use the same process we just learned on our other notes with this given table of values. So remember, our list 1 is all of our x values, our list 2 is all of our y values. So I'm going to pull up my graphing calculator, go into Stat, and Edit. Anything that's in those lists, we clear them out. And then we fill in the x values in list 1, which on number 1 are 1, 3, and 5. And then we put our y values in list 2, which are 6, 18, and 30. Okay, once you have all those saved, remember we just go back and press Stat. This time go over to Calc. And then we choose number 4. It says linear regression. Arrow all the way down to the bottom where it says calculate and press enter. So if you notice right here, we did not get any value for b. So it must show direct variation. So I'm back over here. We got that our m or our a or our k was 6 and that b is 0. This is the part that's important. So the equation of this line would just be y equals 6x. So this one does show direct variation. So yes, and there's the equation of our line. All right. On number 2, same idea. Go back into our calculator, press Stat and Edit. Go in and clear out those lists. And then in list 1, we're going to type our x values, which were -3, 1, and 3. And then in list 2, we're going to put our y values, which were 0, 3, and 6. Once we have all that typed in, we go back to Stat, Calc, choose number 4, go down to Calculate, and press Enter. Alright, so we got some pretty long decimals here for both A and B. But our most important note here should be that B is not 0. Alright, so I'll come back over here. Our M was approximately, we'll just go 3 decimal places, so that would be 0.964. And our B was approximately 2.679. Because this was not 0, this is not showing direct variation. So if you get anything besides 0 for your B, it is not direct variation. All right, next problem says the number of hamburgers that can be made varies directly with the weight of ground beef that is used. 5 hamburgers can be produced for every 2 pounds of ground beef. Write a direct variation equation for the number of hamburgers y that can be made from X pounds of ground beef. Okay, so it says that we need to come up with some line, and then we're going to use this information up here to decide what's representing our x's and what is representing our y's. So they told us that it varies directly, which automatically should let us know that we have a b value of 0 or a y-intercept at 0. Okay. Then it says that the weight of ground beef that is used, if you come down to the bottom, says X pounds of ground beef. That lets us know that X is representing the weight of the ground beef. So weight or pounds of ground beef is our X value. Oops, not that beef. Okay, so in my table over here, my X values are the weight of ground beef. Alright, while our Y is the number of burgers. This side over here is our number of hamburgers that can be made. Alright, so we know that this starts at 0, which would tell us that if we have 0 pounds of ground beef, we can make 0 hamburgers. They also say that 5 burgers can be produced for every 2 pounds. So if you have 2 pounds of meat, you can make 5 burgers. Okay? So I could go type these in my lists. So go to Stat, Edit, clear out what we have in there. In list 1, we list our x's, which are 0 and 2. In list 2, we list our y's, which are 0 and 5. We go to Stat, Calc 4, and calculate. And we do get a p-value of 0 and an a value or a slope of 2.5. Okay? So if our m is 2.5, we need to convert that into a fraction. So go back to our home screen, 2.5, math, enter, enter. And it tells us it's 5 over 2. All right, so we know this thing starts at 0, 0, and this tells me that I need to go up 5 places and over 2. So there's the graph of our line. All right, so let's flip it over onto the back and look at a couple more of these. Number 4 says the mass of a substance varies directly with the volume of the substance. Okay, 80 liters of the substance has a mass of 100 kilograms. What is the volume in liters of 3.2 kilograms of the substance? Okay, so it's going to depend on how much we have of something as to what its mass is, which makes the mass dependent on the volume. We know that our independent is always our x, and our dependent is always our y. So if I was to make a table of values here, x is representing the volume, or how much we have, and then the mass is the mass of however much we did have. Okay, so it says that If this is a direct variation, we automatically know we have that point 0, 0. It also said for 80 liters of the substance, you have a mass of 100 kilograms. So we would just go into our calculator and put these in our lists. So we clear out what's in there. In list 1, we have our x's, which are 0 and 80. Oops. 80, there it goes. And then in list 2, we put in 0 and 100. Once we have those in, we go to Stat, Calc 4, go all the way to the bottom, and press Enter. Alright, so we got A is 1.25, or they called it K on the front, is 1.25. So, if I was to write this equation, I would have y equals 1.25x, and there is no plus b. They also said they want to know what would the volume be of 3.2 kilograms of the substance. Okay, so remember, kilograms was the mass. Okay, so I would take that 3.2, plug it in over here, set it equal to 1.25, and we're solving for x. So I would divide both sides by 1.25 so that we could get x by itself. So in my calculator, I would type in 3.2 divided by 1.25. We would get 2.56 for our x value. So the volume would have to be 2.56 liters. Okay. Number 5, it says that the value of y varies directly with x, so we already know. We got that coordinate point 0, 0 because it said it varied directly. What's the relationship between x and y when we have that x is 18 and y is 24? So we go in to our lists and we type in those values. So I got a 24 in y and an 18 in my list with x, but it still has that coordinate point 0, 0. So once we get those fixed, we go to Stat, Calc 4, and then go down to Calculate and press Enter. Alright, so we get 1.3 repeating. Alright, so we would have K is equal to 1.333, right, repeating, keeps going. Which, if we convert that decimal in our calculator, will become 4/3. So the equation of our line would be 4/3 x. And that would be the function that represents this relationship. Alright, last one. It says the amount of blood in a person's body varies directly. There it goes, varies directly. So we already know we got 0, 0. Okay? With their body weight. A person who weighs 160 pounds has about 4.6 quarts of blood. So we have to ask ourselves, which depends on what? Well, the blood should depend on how much a person weighs. If we don't know how much they weigh, we could not use our function. So weight is the x value, or the independent, and the amount of blood that person has depends on their weight. Alright, so it says that a person who weighs 160 pounds has about 4.6 quarts of blood. What equation could be used to represent this relationship? And they want us to find how many quarts of blood a person who weighs 208.7 pounds might have. So we go back to our stat and edit. Just need to change out my bottom numbers here. So in list 1, I'm going to change that 18 to a 160. And then I'm going to change my 24 to 4.6. Alright, go back to stat, calc 4, go down to calculate, and press enter. And we get 0.02875 for our K. K is equal to 0.02875. So, if I was to write this as an equation, we would have y equals 0.02875x. And they're wanting us to figure out how many quarts of blood a person who weighs this much would have. Well, again, our weight is our x, so that means I need to take that and sub it in for x. So I would have y equals 0.0287 times x, which is 208.7. All we would need to do is multiply these values in our calculator, and we should get something like 6.000125. Okay, and if they wanted us to figure out about how many quarts, we would say around 6 quarts of blood.